Welcome back. So this topic is to explain the impact associated with the types of vulnerabilities. So you can see the list of the types of vulnerabilities, the impact associated with the types of vulnerability, the list. So we can see this one by one. So race conditions or race hat. So race conditions is a behavior of electronics, software, or other systems where the output depends on the sequence or timing of other uncontrollable events. When events don't happen in order the program intent. A race conditions attacks happens when a computer system that designs to handle tasks in a specific sequence is forced to perform two or more operations simultaneously. Others name used to refer to vulnerabilities include time of check, time or time of use, or a TOC. They call it TOC attack. A simple examples of your race condition is a light switch. In some homes, there are multiple light switches connected to a common ceiling lights. When this type of circuit are used, the switch positions becomes irrelevant. Improper input handling. When a system doesn't validate input properly, an attacker is able to craft the input in a form that is not expected by the rest of the application. This will lead to part of the system receiving unintended input, which may result in altered control flow, arbitrary control of resource, or arbitrary code executions. The improper input handling is a term used to describe functions such as validation, sanitizations, filtering, or encoding or decoding input data. Improper input handling is a leading causes of critical vulnerabilities that exist in today's systems and applications. The root causes of improper input handling is application trusting rather than validating data inputs. One of the key aspects of input handling is validating that the inputs satisfy a certain criteria. All inputs should be considered untrusted as they can come from a variety of mechanisms and be transferred in various formats. For proper validations, it is important to identify the form and type of data that is as acceptable and expected by the application. This is required to accurately define restrictions and avoid improper input handling attacks. Improper error handlings. When a system generates an error message that includes sensitive information about its environment, use, or associated data. Vulnerabilities types again, so misconfigurations, weak configurations, using insecure configurations or control settings, example browsers, system policies, like a group policy, so Wi-Fi, so you have to be extra measures, double check with that. Default configurations, often systems, device or software is distributed with insecure default settings. So normally we can't leave this as a default settings. You have to at least set up the secure password or secure configurations, so that will help to protect the data. Weak cipher suits, use of older or less robust cryptographic algorithm for encryption data, example TES WEP. So weak cipher is defined as an encryption and decryption algorithms that uses a key insufficient length. Using an insufficient length for a key in an encryption decryption algorithms open up the possibility that the encryption schemes could be broken. Example cracked. So the next one is improper certifications and key management, allowing unauthorized access to encryption keys or certifications allow sensitive data to be decrypted, also allowing digital certificate to expire. Improperly configured accounts. Accounts have greater privilege than is need to perform a functions, solved by least privilege. So at least you need to configure this least privilege that will help to protect the privacy. The next one is resource exhaustion. a simple denial of service condition that happens when the resource required to execute an action or entirely expanded prevent that action from occurring. Resource exertions attacks generally exploit a software bug or design deficiency in software with manual memory management, most commonly written in C or C++. Memory leaks are a very common bug exploited for resource exhaustions. Even if your garbage collected program language is used, resource exhaustions attacks are possible if the program uses memory inefficiently and does not impose limits on the amount of state used when necessary. File descriptions leaks are another common vector. Most general purpose program language requires the programmer to explicitly close the descriptors, so even particularly high-level language allow the program to make such a mistake. So next one is a vulnerable business process, as known as a business process compromise, silently altering the part of specific business process or machine facilitating these processes in order to gain access to systems or generate monetary profit for the attacker. Vulnerability types. So system sprawl, undocumented assets, allowing unchecked systems or device on an internal network, lack of internal inventory system, architecture design weakness, and insecurely designed networks or systems architecture. Examples: not segmenting systems on an internal network. Vulnerability types. Vulnerability due to EOL, end of life systems, embedded systems, lack of vendor support. So these main three types is very important. So vulnerability types. Again, so the last ones, memory buffer vulnerabilities. It's a memory leaks, integer, buffer overflow, pointer difference, and then DLL injections. So that the last one is completed. So we have a lot of tools over there, so you can find the open source, OpenVAS, Nessus. These all are the vulnerability scan tools. We will talk about this later. So there will be a video for only for lab. So you will see in the later on video. So that these questions now, in these types of vulnerabilities, account have greater privilege than is needed to perform your functions and is solved by least privilege. Answer: improperly configured account. Answer is improperly configured account. So that's it, guys, today's video. Please subscribe, share my video to your friends, press the bell button. Bye for